Hello, in this lecture you will find out the values of line segments X and Y. In the drawing we have square DEBF we know that one side of this square equals to 1 unit, so all of its sides are equal to 1 unit, and the square is inside the right triangle ABC, and the hypotenuse AC of the right triangle ABC equals to 3 units, and we want to find out the value of line segment FC that equals to X and the value of line segment AD that equals to Y. So first of all, we know that the opposite sides of a square are parallel to each other. That is to say, DE is parallel to BF, and BC is one side of the right triangle ABC, therefore it is a straight line. BC, if a side of a triangle, is a straight line. BC is a straight line. And part of the straight line BC, that is to say BF, is parallel to DE. So if part of the straight line BC is parallel to DE, then the straight line itself BC will be also parallel to DE. So BC is parallel to DE. And we also have rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I will read rule number 1 again. According to rule number 1, corresponding angles between parallel lines are equal to each other. So actually, those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. Therefore, they are equal to each other according to rule number 1. So we can find out that angle AED, this angle, equals to this angle that is actually angle ECF. I repeat again, angle AED equals to angle ECF. According to rule number 1, those two corresponding angles are located between the parallel line DE and BC, therefore they are equal to each other. And we have also rule number 2, but before that we will define angle ADE as theta. Again, angle ADE equals to theta according to our definition. So from this equation, theta equals to AED equals to angle EFC, we will derive that angle ECF also equals to theta. Angle ECF also equals to theta. So here we can write down that angle ECF equals to theta. So we have here two angles that are equal to each other, and both of them are equal to theta according to our definition. In the next step I will present to you a new rule that is actually rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. I repeat again on rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that AB is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. AB as a side of a triangle is a straight line. AB is a straight line. And we define angle ADE as X. So if we focus on this side of the straight line AB at point D, then the sum of the angles here must be equal to 180 degrees. That is to say, this angle is equal to 90 degrees plus the size of angle X. In total they must be equal to 180 degrees. So I write it down. 90 degrees plus the size of angle X in total must be equal to 180 degrees. So here we'll subtract 90 degrees from this equation and we'll get that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle X equals to 90 degrees. So I will substitute angle X by a right angle. Therefore, triangle ADE is a right triangle. Likewise, BC is one side of the right triangle, triangle ABC, therefore it is absolutely a straight line. BC is a straight line. And if we focus on the upper side of the straight line BC at point F, and we define angle EFC as Y, then angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. So angle Y plus 90 degrees must be equal to 180 degrees according to rule number 2. So here we'll subtract 90 degrees from this equation and we'll get that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So angle Y equals to 90 degrees. So we can substitute angle Y by a right angle. Therefore, triangle EFC is also a right triangle. So in the next step, we'll focus on the right triangle, triangle ADE. On the right triangle, triangle ADE. Tangent theta will be equal to AD over DE. I'll repeat again. In the right triangle, triangle ADE, tangent theta equals to AD over DE. But AD equals to Y, according to what is given us in the question, and DE equals to 1. So, in conclusion, we found out that tangent theta equals to Y. According to equation number 1, tangent theta equals to Y. In the next step, we will focus on triangle EFC, this right triangle. In triangle EFC, tangent theta equals to EF over FC. In the right triangle, triangle EFC, tangent theta equals to EF over FC. Here EF equals to 1 unit and FC equals to X. So in conclusion, we found out that tangent theta according to equation number 2 equals to 1 over X. So here we will create equation number 3 that states that tangent theta according to equation number 2 must be equal to tangent theta according to equation number 3. So tangent theta according to equation number 1 is y, and it must be equal to tangent theta according to equation number 2, that is 1 over x. So according to equation number 3, we found out that y equals to 1 over x. We will multiply equation number 3 by x, and we will get that according to equation number 3, x times y equals to 1. Whenever the multiplication of two numbers is equal to 1, it means that 1 is the inverse number of the other. So here we can write down that x is the inverse number of y. And it is also true to say that y is the inverse number of x. Okay, and we have rule in relation to inverse number. The rule is that each number has only one inverse number. Each number has only one inverse number. For example, 1 over 5 is the inverse number of 5, and 1 over 5 is the only inverse number of 5, and 1 over 5 is the inverse number, and 5 is the inverse number of 1 over 5, and only 5 is the inverse number of 1 over 5. Okay? In the next step, we will focus on the right triangle ABC. In the right triangle ABC, according to the Pythagoras theorem, the square of the hypotenuse is equal to the sum of the squares of the perpendiculars. The hypotenuse is AC, and the square of the hypotenuse is AC squared. So AC squared equals to the sum of the squares of the perpendiculars. That is to say, it equals to AB squared plus BC squared. I'll repeat again. In the right triangle ABC, according to the Pythagoras theorem, here the letters P and T is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC squared equals to AB squared plus BC squared. Here, AC equals to 3 units according to what is given us in the question. So AC squared will be equal to 3 squared. 3 squared is 9. And it equals to AB squared. AB equals to y plus 1. So AB squared will be equal to y plus 1 squared. Plus BC squared. BC equals to x plus 1. Therefore, BC squared will be equal to x plus 1 squared. In conclusion, we found out that according to equation number 4, 9 equals to y plus 1 squared plus x plus 1 squared. Here we will open the brackets on this side of equation number 4, and we will get that according to equation number 4, y plus 1 squared is y squared plus 2y plus 1 plus x plus 1 squared, x plus 1 squared is x squared plus 2x plus 1, and it equals to 9. And we also know that according to equation number 3, y is equal to 1 over x. So therefore we can substitute y by 1 over x in equation number 4. We'll do it now, and we'll get that y squared is 1 over x squared plus 2y is plus 2 times 1 over x plus 1 plus x squared plus 2x plus 1 equals to 9. Here we will organize the expressions inside equation number 4 in a different way. Here we have x squared plus 1 over x squared plus 1 plus 1 is 2 plus 2 plus 2x plus 2 times 1 over x equals to 9. Here the expression inside the brackets x squared plus 1 over x squared plus 2 is equal to x plus 1 over x squared. Here we will take 2 as a common factor out of those two expressions, and we will get that inside the brackets we will have here x. This is what is left after we took 2 as a common factor, and what is left from 2 times 1 over x after we took from it 2 as a common factor. What is left? It is actually 1 over x, that equals to 9. Here we will subtract 9 from this equation, and we will get that x plus 1 over x squared plus 2 times x plus 1 over x minus 9 equals to 0. Here we will define t as x plus 1 over x, that is to say t equals to x plus 1 over x according to our definition. So now we can substitute x plus 1 over x in equation number 4 by t. So we'll do it now, and we will get that according to equation number 4, x plus 1 over x squared is t squared plus 2 times x plus 1 over x is 2t minus 9 equals to 0. So we got here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay, and in our specific equation, quadratic equation, t squared plus 2t minus 9 equals to 0. Here the variable that we are looking for is t, so x equals to t, and the coefficients of this quadratic equation are as follows: a equals to 1, b equals to 2, and c equals to minus 9. Now the only thing that is left to do is to put the data inside the equation for x in order to find out the value of t, because x equals to t. So we'll get that, we'll do it now, and we'll get that t equals to minus b, b is 2, so minus b is minus 2, plus minus square root of b squared, b equals to 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a is 1, and c is 9, so minus 4 times minus 9 is plus 36, over 2a, a is 1, so 2 times 1 is 2, and there 4 plus 36 is 40, so I write it down. We got that t equals to minus 2 plus minus square root of 40 over 2. So here 40 is 4 times 10, and the square root of 4 is 2, so I write it down. We will get that t equals to minus 2 plus minus 2 times square root of 10 over 2. And so we got that t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1, so we left here square root of 10. So in conclusion, we found out that t equals to minus 1 plus minus square root of 10. So we have here two solutions that are possible for t. The first solution is t equals to minus 1 plus square root of 10, and the second solution for t is t equals to minus 1 minus square root of 10. Okay, so we focus on the second solution for t, that is actually t equals to minus 1 minus square root of 10. According to our definition, t equals to x plus 1 over x, that equals to minus 1 minus square root of 10. Here you can see in the drawing that x is the length of the right triangle EFC, therefore it must be a positive number, and 1 over x must be also a positive number, therefore x plus 1 over x must be a positive number. But according to the solution for t, it equals to minus 1 minus square root of 10. Minus 1 minus square root of 10 is a negative number. So we got here to the solution that a positive number is equal to a negative number. That is, of course, is not true, so we have here a contradiction. Therefore, the second possibility for the solution for t, that is minus 1 minus square root of 10, is not correct. We will cancel this possibility, and we left only with the solution that t equals to minus 1 plus square root of 10. T is x plus 1 over x according to our definition, and it equals to square root of 10 minus 1. Here we will multiply x by x and then we will divide it by x in order to overcome a factor with 1 over x, and we will get that x squared plus 1 over x equals to square root of 10 minus 1. Here we will multiply this equation by x, and we will get that x squared plus 1 equals to square root of 10 minus 1 times x. Here we will subtract square root of 10 minus 1 times x from this equation, and we will get that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. So we got here a quadratic equation. In this quadratic equation, the coefficients are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general solution for a quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So x equals to minus b, b is minus square root of 10 minus 1, so minus and minus is plus, and we will get that in conclusion that minus b equals to square root of 10 minus 1 plus minus square root of b squared is square root of 10 minus 1 square minus 4 times a times c. Minus 4 times a is 1 and c is 1, so it is minus 4 over 2a. A is 1, so 2 times a is 2 times 1, that is 2. So we have here, we got that x equals to square root of 10 minus 1 plus minus, here we have square root of 10 minus 1 squared. We will calculate the value of this expression according to the algebraic identity that states that a minus b squared equals to a squared plus b squared minus 2 times ab. A is square root of 10 and b is 1, so square root of 10 squared is 10 plus b squared. B is 1, so 1 squared is 1. Minus 2 times ab is minus 2 times square root of 10 times 1 minus 4, all divided by 2. So we actually found out that x equals to square root of 10 minus 1 plus minus, and here we have 10 plus 1 is 11, 11 minus 4 is 7, minus 2 times square root of 10 divided by 2. Okay, I'll repeat again, x equals to square root of 10 minus 1 plus minus square root of 7 minus 2 times square root of 10 over 2. So here we'll focus on the expression that is inside the root, that is actually 7 minus 2 times square root of 10. Again, the expression inside the root is 7 minus 2 times square root of 10, and we will change this expression. Here 7, we'll substitute 7 by 5 plus 2 minus 2 times square root of 10, and we'll substitute square root of 10 by square root of 5 times square root of 2. And here we have 5 plus 2 minus 2 times square root of 5 times square root of 2. Here we'll substitute 5 by square root of 5 square, because 5 equals to square root of 5 square. And we'll substitute 2 by square root of 2 square. Square root of 2 square is 2. Minus 2 times square root of 5 times square root of 2. Here, this expression, square root of 5 square plus square root of 2 square minus 2 times square root of 5 times square root of 2, is very similar to the algebraic identity that states that a square plus b square minus 2 times a times b equals to a minus b square. That is to say, we can substitute our expression by a minus b square, and in our specific expression a equals to square root of 5 and b equals to square root of 2. Therefore, we substitute our expression by square root of 5 minus square root of 2 square. And those two expressions are equal to each other according to the algebraic identity that a square plus b square minus 2 times ab equals to a minus b square. And in our specific expression, a minus b square is square root of 5 minus square root of 2 square. Okay, so in conclusion, we found out that the expression 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 square. That is to say, we can substitute the original expression that is inside the root, that is 7 minus 2 times square root of 10 by square root of 5 minus square root of 2 square. So we'll do it now, and we will get that x equals to square root of 10 minus 1 plus minus, and I repeat again, we'll substitute the expression that is inside the root, that is 7 minus 2 times square root of 10, by the expression that is equal to it, that is actually square root of 5 minus square root of 2 square, all divided by 2. So we got here that x equals to square root of 10 minus 1 plus minus. Here we have square and root. The square cancels the root, and we left only with square root of 5 minus square root of 2, all divided by 2. So here we will have two solutions that are possible for x. The first solution, we'll define the first solution as x1 and the second solution as x2. The first solution, x1, will be equal to square root of 10 minus 1 plus square root of 5 minus square root of 2 divided by 2. And the second solution will be x2 and x2 will be equal to square root of 10 minus 1 minus square root of 5 minus square root of 2 divided by 2. So we'll continue with the first solution for x, that is x1. Here we have x1 that equals to square root of 10 minus square root of 10 minus 1 plus square root of 5 minus square root of 2 divided by 2. Here we will substitute square root of 10 by square root of 5 times square root of 2, and we will get that square root of 10 is square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. So here we will take square root of 5 as a common factor out of those two expressions. So square root of 5 is a common factor. What is left from square root of 5 times square root of 2 after we took from it square root of 5 is a common factor? What is left from it is actually square root of 2. And what is left from square root of 5 after we took from it square root of 5 as a common factor? What is left from it is actually 1. And we have also minus 1 minus square root of 2. Here we will take a common factor of minus 1 from those two expressions. So we have minus 1 is a common factor, and inside the brackets we will have here 1 square root of 2 plus 1. So we took minus 1 as a common factor from those two expressions, that is to say from minus 1 and minus 2 square, minus square root of 2, and we got that inside the brackets we have square root of 2 plus 1, all divided by 2. So here we'll take square root of 2 plus 1 as a common factor out of these expressions. So what left of this expression after we took from it square root of 2 plus 1 as a common factor? What is left from it is square root of 5. And what is left from minus square root of 2 plus 1 after we took from it square root of 2 plus 1 as a common factor? What is left from it is actually minus 1, all divided by 2. So in conclusion, we found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. We'll do the same process for x2, and we get here that x2 equals to square root of 10 minus 1. Here we have minus before the bracket, so we will have here minus square root of 5. And here we have minus and minus is plus, so it will be plus square root of 2 over 2. We have here x2 that equals to square root of 10. We will substitute square root of 10 by square root of 5 times square root of 2. So here we will take square root of 5 as a common factor out of those two expressions. So square root of 5 is a common factor, and inside the brackets from this expression what is left is square root of 2, and from this expression what is left after we took from it square root of 5 is a common factor, what is left it is actually minus 1, and we have also square root of 2 minus 1, all divided by 2. So here we have x2 that equals to, here we take square root of 2 minus 1 as a common factor from those two expressions. And what is left from this expression after we took from it square root of 2 minus 1 as a common factor? What is left from it? It is actually square root of 5 So what is left from square root of 2 minus 1 after we took from it square root of 2 minus 1 as a common factor? What is left from it is actually square root of 5 plus 1, all divided by 2. So in conclusion, we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2, and x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So in the next step, I will copy the values of x1 and x2 in a new page, and we will multiply x1 by x2. Okay, so we actually found out that x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2 and x2 equals to square root of 2 minus 1 times square root of 5 plus 1 divided by 2 . In the next step, we will multiply x1 by x2. So x1 times x2 will be equal to square root of 2 plus 1 times square root of 5 minus 1 over 2. This is x1, and we will multiply it by x2. x2 is square root of 2 minus 1 times square root of 5 plus 1, all divided by 2. In the next step, we will change the order of the expressions inside the multiplication of x1 times x2, and we will get that x1 times x2 actually equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 2 times 2. 2 times 2 is 4, so I'll write it down. So now we will calculate the value of square root of 2 plus 1 times square root of 2 minus 1 according to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here, square root of 2 plus 1 times square root of 2 minus 1 is very similar to the expression a plus b times a minus b. So it must be equal, our expression must be equal to a squared minus b squared. And in our specific expression, a equals to square root of 2 and b equals to 1. Therefore, a squared will be equal to square root of 2 squared, that is actually 2 minus b squared. B is 1, so b squared is 1 squared, 1 squared is 1. So in conclusion, we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1. And likewise, we'll calculate the value of square root of 5 plus 1 times square root of 5 minus 1. Here, a equals to square root of 5 and b equals to 1. Therefore, a squared is square root of 5 squared, that is 5, minus b squared, b is 1, so b squared is 1 squared, 1 squared is 1. So in conclusion, we found out that square root of 5 times square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1. And in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 4. 2 minus 1 is 1, 5 minus 1 is 4 over 4. 1 times 4 is 4, and 4 over 4 is 1. That is to say, x1 times x2 equals to 1. Okay? So, we found out that x1 times x2 equals to 1. What does this equation means? It means that x1 is the inverse number of x2, and it is also true to say that x2 is the inverse number of x1. Okay? And according to equation number 3, we found out that x times y equals to 1. It also means that x is the inverse number of y and y is the inverse number of x. But we will put the solutions to the question inside equation number 3. We have two solutions to the question. The first solution is x1, y1, and the second solution is x2, y2. So if we put the first solution inside equation number 3, we will get that x equals to x1 and y equals to y1, and we will get that x1 times y1 equals to 1. So what is the meaning of this equation that x1 times y1 equals to 1? It means that y1 is the inverse number of x1. Okay, y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. Okay, so we have two numbers, that is to say y1 and x2, that both of them are the inverse number of the same number, that is x1. But x1 can have only one inverse number, according to the rule that I mentioned in the beginning of the lecture. X1 can have only one inverse number. Therefore, we have to conclude that y1 must be equal to x2, otherwise we will get that x1 has more than one inverse number. Okay, and because of the fact that x1 is only one inverse number, y1 must be equal to x2. Likewise, we will put the second solution to the question inside the question number 3. The second solution to the question the values for x and y is x2 and y2, and we will put it inside the question number 3 that states that x times y equals to 1. Here x equals to x2 and y equals to y2. So we get that according to equation number 3, after we put the solution inside the equation number 3, we will get that x2 times y2 equals to 1. And what is the meaning of this equation? X2 times y2 equals to 1. It means that y2 is the inverse number of x2. Okay, y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. So we actually have two numbers, that is actually y2 and x1, that both of them are the inverse number of x2. And x2 can have only one inverse number. And because of the fact that x2 can have only one inverse number, we must conclude that y2 equals to x1. Okay? And we have already found out that y1 equals to x2. Now we can present the solution to the question. We have two solutions to the question. The first solution to the question is x1, y1. The values of x and y are x1 and y1. And actually x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2, and y1, we actually found out that y1 equals to x2. So y1 that equals to x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. So this is the first solution to the question, and the second solution to the question is x2, y2. We have already found out that x2 is square root of 2 minus 1 times square root of 5 plus 1 divided by 2, and we found out that y2 equals to x1. So y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 divided by 2. So those are the two solutions to the question, x1 and y1, x2 and y2. In the next step, I will summarize the lecture. Actually, we wanted to find out the values of line segments x and y. We have a square that is inside a right triangle in the drawing, and I repeat again, we have here square DEBF. We know that one side of this square is equal to 1 unit. The square is inside the right triangle, triangle ABC. We know that the hypotenuse of the right triangle, triangle ABC, that is to say AC equals to 3 units, and we want to find out the values of line segment FC that equals to X and line segment AD that equals to Y. So we have a rule that states that the opposite sides of a square are parallel to each other, that is to say DE is parallel to BF, DE is parallel to BF, BC is one side of the right triangle ABC, therefore it is absolutely a straight line. Okay, so BC is a straight line, and we know that part of the straight line BC, that is actually BF, is parallel to BE. So because of the fact that part of BC is parallel to DE, then BC itself, the straight line BC itself, will be also parallel to DE. So we can write down that BC is parallel to DE. Then I presented to you rule number 1. According to rule number 1, corresponding angles between parallel lines are equal to each other. So those two angles are defined as corresponding angles, and they are located between the parallel lines DE and BC. We've already proved that DE is parallel to BC. And because of the fact that those two corresponding angles are located between the parallel lines DE and BC, they are equal to each other. That is to say, angle AED equals to angle ECF according to rule number 1. Okay? Those two angles are equal to each other according to rule number 1. And if we define angle AED as theta, angle AED equals to theta according to our definition, then from this equation, angle theta equals to angle AED equals to angle ECF, we will derive that angle ECF also equals to theta. So this angle also equals to theta. So those two angles, they are both equal to each other, and they are both equal to theta. Then I presented to you rule number 2. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, and actually we have side AB is one side. AB is one side of the right triangle ABC, therefore it is absolutely a straight line, a side of a triangle, it is absolutely a straight line. So we can write down that AB is a straight line. So if we focus on this side of the straight line AB at point D, here we define angle ADE as X. So angle X plus 90 degrees must be equal to 180 degrees according to rule number 2. That states that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, in the straight line AB, 90 degrees plus angle X must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we got that angle X equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that this angle equals to 90 degrees. Then BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So BC is a straight line. So if we focus on the upper side of the straight line BC at point F, then the sum of the angles at this point must be equal to 180 degrees. So if we define angle EFC as Y, then Y plus 90 degrees must be equal to 180 degrees according to rule number 2. Y plus 90 degrees must be equal to 180 degrees according to rule number 2. Here we subtracted 90 degrees from this equation, and we got that angle Y equals to 180 degrees minus 90 degrees is 90 degrees. So we got here that this angle equals to 90 degrees, therefore triangle EFC is a right triangle, as well as triangle ADE is also a right triangle. Then we focus on the right triangle ADE. In this right triangle, tan theta equals to AD over DE. in the right triangle, triangle ADE, tangent theta equals to AD over DE, AD equals to Y, DE equals to 1. Therefore, tangent theta equals to Y, according to equation number 1. Then we focus on the right triangle, triangle EFC. In this right triangle, triangle EFC, tangent theta equals to EF over FC. Tangent theta equals to EF over FC. EF equals to 1. FC equals to X. EF equals to 1. FC equals to X. So, in conclusion, we found out that according to equation number 2, in the right triangle, triangle EFC, tangent theta equals to 1 over X. Then we created equation number 3 that states that tangent theta according to equation number 1 must be equal to tangent theta according to equation number 2. So, tangent theta according to equation number 1 is Y, and tangent theta according to equation number 2 is 1 over X. Therefore, Y must be equal to 1 over X. So, we got the equation number 3 that states that Y equals to 1 over X. Then we multiply the equation number 3 by X, and we got that X times Y equals to Y. X times Y equals to 1. X times Y equals to 1, and whenever you multiply two numbers by each other and you got the result of 1, it means that each number is the inverse number of the other. In this case, that X times Y equals to 1, it means that X is the inverse number of Y, and Y is also the inverse number of X. And we have also the rule that each number has only one inverse number. Okay? Each number has only one inverse number. The inverse number of 5, is 1 over 5, and it is only 1 over 5. 5 has no other inverse number than 1 over 5. Okay, then we focus on the right triangle, triangle ABC. In this right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AC, so the square of the hypotenuse is AC square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to AB square plus BC square. Again, according to equation number 4, in the right triangle, triangle ABC, AC square equals to AB square plus BC square. AC equals to 3, it is given as the question. So AC square is 3 square is 9, and it equals to AB square. AB equals to Y plus 1, so AB square is Y plus 1 square, and plus BC square. BC is X plus 1, so BC square is X plus 1 square. So in conclusion, we found out that according to equation number 4, AC square equals to AB square plus BC square. According to equation number 4, 9 equals to Y plus 1 square plus X plus 1 square. Here we open the brackets on this side of equation number 4, and we got that Y plus 1 square equals to Y square plus 2Y plus 1, and X plus 1 square equals to X square plus 2X plus 1, and all equals to 1 and to 9. We have 9 in the other side of the equation. So here, but we have equation number 3 that states that Y equals to 1 over X. That is to say, we can substitute Y in equation number 4 by 1 over X. We did it, and we got that Y square is 1 over X square, plus 2Y is plus 2 times 1 over X, plus 1 equals to X square, plus 2X plus 1, that equals to 9. So then I put the equation number 4 in a different order. I organized the equation number 4 in a different order, and we got that X square plus 1 over X square plus 2 plus 2X plus 2 times 1 over X equals to 9. So inside the brackets, X square plus 1 over X square plus 2 is actually, this expression equals to X plus 1 over X square, and plus, here we have 2X plus 2 times 1 over X. We took 2 as a common factor out of those two expressions, and from this expression what is left is x, and from this expression, what is left after we took from it 2 as a common factor, what is left is 1 over x. So in conclusion, we found out that according to equation number 4, x plus 1 over x squared plus 2 times x plus 1 over x equals to 9. Here we subtracted 9 from this equation and we found out that x plus 1 over x squared plus 2 times x plus 1 over x minus 9 equals to 0. Here we defined t as x plus 1 over x. That is to say t equals to x plus 1 over x according to our definition. Now we can substitute x plus 1 over x by t. We did it and we got that x plus 1 over x squared is t squared. 2 times x plus 1 over x is 2t minus 9 equals to 0. So we got here a quadratic equation where t is the missing variable, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0, and a, b, and c in this quadratic equation are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we will find out the value of x according to a special formula for x. The special formula for x is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And in our specific quadratic equation, that is t squared plus 2t minus 9 equals to 0, the variable that we are looking for is t, so x equals to t. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to 2, c equals to minus 9. So we put the data inside the general formula for x, and we found out that x equals to t, that equals to minus b, b equals to 2, so minus b is minus 2, plus minus b squared, b is 2, so b squared is 2 squared, 2 squared is 4, minus 4 times a times c, so minus 4 times a is 1, and c is minus 9. Minus 4 times minus 9 is plus 36, so inside the root we have 4 plus 36, all divided by 2, so t equals to minus 2 plus minus 36 plus 4 is 40 over 2. But 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that t equals to minus 2 plus minus 2 times square root of 10 over 2. So here we divided this equation by 2, and minus 2 over 2 is minus 1. 2 over 2 is 1, so in conclusion we found out that t equals to minus 1 plus minus square root of 10. So here we will have two solutions that are possible for t. The first solution for t is t equals to minus 1 plus square root of 10, and the second solution is t equals to, for t is t equals to minus 1 minus square root of 10. So we focused on the second solution for t. The second solution, t according to our definition is x plus 1 over x, and x plus 1 over x according to the second solution must be equal to minus 1 minus square root of 10. But x is the length. X is the length of one side of the right triangle EFC, therefore it must be a positive number, and 1 over x also must be a positive number, therefore x plus 1 over x must be a positive number. So in this side of the equation we have a positive number, and in the other side of the equation we have minus 1, that is minus 1 minus square root of 10, that is a negative number. And a positive number can never be equal to a negative number, therefore we got to a contradiction. Therefore this solution is incorrect solution, so we cancel this solution, and we have only one solution to the question for this quadratic equation, that is t equals to minus 1 plus square root of 10. t is x plus 1 over x according to our definition, so we substitute t by x plus 1 over x, and we got that x plus 1 over x equals to square root of 10 minus 1. Here we multiplied this side of the equation, we multiplied x by x, and then we divided by x in order to have a common factor. We found 1 over x, and we got that x squared plus 1 over x equals to square root of 10 minus 1. Here we multiplied this equation by x, and we got that x squared plus 1 equals to square root of 10 minus 1 times x. So we substituted square root of 10 minus 1 times x from this equation, and we got the quadratic equation that x squared minus square root of 10 minus 1 times x plus 1 equals to 0. The coefficients of this quadratic equation are as follows: a equals to 1, b equals to minus square root of 10 minus 1, and c equals to 1. And the general solution for quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So the only thing that is left to do is to put the data inside x, inside the formula for x, and to find out the value of the values of x. So we did it, and we got that x equals to minus b. B is minus square root of 10 minus 1, so minus b is minus, and minus is plus. So here we have b minus b equals to minus b equals to square root of 10 minus 1 plus minus b squared. B equals to minus square root of 10 minus 1, so b squared is square root of 10 minus 1 squared minus 4 times ac. A is 1, c is 1, so minus 4 times ac is minus 4, all divided by 2. So x equals to square root of 10 minus 1 plus minus. Here we did the calculation of square root of 10 minus 1 squared. According to the algebraic identity, it states that a minus b squared equals to a squared plus b squared minus 2 times ab. Here a equals to square root of 10, so a squared is square root of 10 squared. Square root of 10 squared is 10, plus b squared. B is 1, so b squared is 1. Minus 2 times ac is minus 2 times square root of 10. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus 10 plus 1 minus 2 times square root of 10 minus 4 over 2. Here we got that x equals to square root of 10 minus 1 plus minus, and inside the root we have 10 plus 1 is 11, and 11 minus 4 is 7. So inside the root we have 7 minus 2 times square root of 10, and all divided by 2. Then we focused on the expression that is inside the root. The expression that is inside the root, it is actually 7 minus 2 times square root of 10. Here we substituted 7 by 5 plus 2, and we substituted square root of 10 by square root of 5 times square root of 2. So we got that 7 minus 2 times square root of 10 equals to 5 plus 2 minus 2 times square root of 5 times square root of 2. Here we substituted 5 by square root of 5 squared, and we substituted 2 by square root of 2 squared. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 squared plus square root of 2 squared minus 2 times square root of 5 times square root of 2. But this expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared. That is to say, we can substitute our specific expression by a minus b squared when a equals to square root of 5 and b equals to square root of 2. We did it, and we got that our expression, according to this algebraic identity, will be equal to square root of 5 minus square root of 2 squared. So in conclusion, we found out that 7 minus 2 times square root of 10 equals to square root of 5 minus square root of 2 squared. That is to say, we can substitute the expression that is inside the root, that is 7 minus 2 times square root of 10, by square root of 5 minus square root of 2 squared. We did it, and we got that x equals to square root of 10 minus 1 plus minus, and I repeat again, we substituted 7 minus 2 times square root of 10 by square root of 5 minus square root of 10 squared, and all divided by 2. And here we have root and square. The square cancels the root, and we left only with square root of 5 minus square root of 2. So in conclusion, we found out that x equals to square root of 10 minus 1 plus minus square root of 5 minus square root of 2 over 2. So here we will have two solutions that are possible for x. The first solution will be defined as x1, and the second solution we defined it as x2. The first solution, x1, is square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. And the second solution for this quadratic equation is x2, that equals to square root of 10 minus 1 minus square root of 5 minus square root of 2 over 2. Okay, so I'll continue with the first solution, x1. Here I open the brackets, and we got that x1 equals to square root of 10 minus 1 plus square root of 5 minus square root of 2 over 2. Then I substituted square root of 5, I substituted square root of 10 by square root of 5 times square root of 2. So, and we got that x1 equals to square root of 5 times square root of 2 minus 1 plus square root of 5 minus square root of 2 over 2. Then we took square root of 5 as a common factor out of those two expressions. So we will have that x1 equals to here square root of 5 was taken out as a common factor, and from this expression what is left is square root of 2, and from this expression what is left is 1. So in conclusion, we got that x1 equals to square root of 5 times square root of 2 plus 1 minus square root of 2 plus 1 over 2. Here we took square root of 2 plus 1 as a common factor out of these two expressions, and we got that x1 in conclusion equals to square root of 2 plus 1 was taken as a common factor, and from this expression what is left is square root of 5, and from this expression what is left after we took from it square root of 2 plus 1 as a common factor, what is left is it is actually minus 1, and in conclusion we found out that x1 equals to square root of 2 plus 1 times square root of 2 minus 1 over 2. Then we continued with x2. Here we have x, so we open the brackets here, and we got that x2 equals to square root of 10 minus 1 minus square root of 5, and here we have minus and minus is plus, so it is plus square root of 2 over 2. Then we substituted square root of 10 by square root of 5 times square root of 2, and we got that x2 equals to square root of 5 times square root of 2 minus 1 minus square root of 5 plus square root of 2 over 2. Then we took square root of 5 as a common factor out of those two expressions, and we got that x2 equals to square root of 5 is taken as a common factor out of these two expressions. What is left from this expression after we took from it square root of 5 is what is left is it is actually square root of 2, and what is left from these expressions after we took from it square root of 5 as a common factor, what is left it is actually minus 1. So in conclusion we found out that x2 equals to square root of 5 times square root of 2 minus 1 minus plus square root of 2 minus 1 over 2. Here we took square root of 2 minus 1 as a common factor out of those two expressions, and we got that x2 equals to square root of 2 minus 1 is taken as a common factor, and what is left from this expression after we took from it square root of 2 minus 1 as a common factor, what is left from it is square root of 5, and what is left from this expression after we took from it square root of 2 minus 1 as a common factor, what is left it is actually 1, and in conclusion we found out that x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. Okay, then we multiplied x1 by x2. First of all, I copied the expressions for x1 and x2, and we multiplied x1 by x2. Then I organized the expressions inside the x1 times x2 in a different order, and we got that x1 times x2 equals to square root of 2 plus 1 times square root of 2 minus 1 times square root of 5 plus 1 times square root of 5 minus 1 over 1. So here the expression square root of 2 plus 1 times square root of 2 minus 1 is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. In our specific expression, a equals to square root of 2 and b equals to 1. So this expression equals to a squared minus b squared. So a squared is square root of 2 squared, that is 2, and b squared, b equals to 1, so b squared is 1 squared, 1 squared is 1. So we found out that square root of 2 plus 1 times square root of 2 minus 1 equals to 2 minus 1, that is 1. Then we did the same process for the expressions of square root of 5 plus 1 times square root of 5 minus 1. Here a equals to square root of 5 and b equals to 1. So this expression must be equals to a squared minus b squared. A equals to square root of 5, so a squared is square root of 5 squared, that is 5, minus b squared, b is 1, so b squared is 1 squared, and minus b squared is minus 5. So in conclusion, we found out that square root of 5 plus 1 times square root of 5 minus 1 equals to 5 minus 1, that is 4. And in conclusion, we found out that x1 times x2 equals to 2 minus 1 times 5 minus 1 over 4. 2 minus 1 is 1, 5 minus 1 is 4, 1 times 4 is 4, and 4 over 4 is 1. So in conclusion, we found out that x1 times x2 equals to 1. x1 times x2 equals to 1, and what is the meaning of the equation x1 times x2 equals to 1? It means that x1 is the inverse number of x2 and x2 is the inverse number of x1. Then we have equation number 3 that states that x times y equals to 1. And we have two solutions to the question. The first solution to the question is x1, y1, and the second solution to the question is x2, y2. We put the first solution to the question inside equation number 3. That is to say x equals to x1, y equals to y1, and we got the equation number 3 that states that x1 times y1 equals to 1. What does it mean? It means that y1 is the inverse number of x1. But we have already found out that x2 is the inverse number of x1. And we know that any number, or every number, has only one inverse number. We have two numbers that are the inverse number of x1, but x1 can have only one inverse number. Therefore, we must conclude from it that y1 is equal to x2. Okay? Likewise, we put the second solution to the question, that is to say x2, y2, inside equation number 3, xy equals to y. Here x equals to x2 and y equals to y2. And we got that x2 times y2 equals to 1. What does it mean? It means that y2 is the inverse number of x2. But we have already found out that x1 is the inverse number of x2. So we have two numbers, that is to say y2 and x1, that are the inverse number of the same number, that is x2. But any number or every number is only one inverse number. So y2 must be equal to x1 in order to obey to the rule that any number has only one inverse number. So if we have two numbers that are the inverse number of a specific number, then they must be equal to each other. That is to say, y2 is equal to x1, and we have already found out that y1 is equal to x2. So the solution to the question is, we have two solutions. The first solution to the question is x1, y1, when x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. And y1 is equal to x2. So y1 that equals to x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. This is the first solution, x1, y1. And the second solution to the question is x2, y2. When x2 equals to square root of 2 minus 1 times square root of 5 plus 1 over 2. and y2. y2 is equal to x1. y2 is equal to x1, so y2 that equals to x1 equals to square root of 2 plus 1 times square root of 5 minus 1 over 2. So those are the two solutions to the question, x1, y1 and x2, y2. Okay, thank you very much.